Hi guys, welcome to my YouTube channel. In this tutorial, I'm going to be showing you how to use worker threads in ElectronJS to isolate operations that are computational expensive and that can block the main threads to a separate worker thread. This is what we are going to be doing in this tutorial. I'm just going to show you how it works. Now, there are three buttons here. One button to increase this number and another button to run a computational expensive operation and another one that runs the same operation in a worker thread. Yeah, now if I click on this button, the button is still working. Now once I click on this main thread, and you see that the main thread has been blocked. Now it has resumed after the operation finished. Now if we run the same operation in a worker thread, you see that it's going to the issue we just experienced. Now we are not going to experience it. Yeah, now if I click on this button, it is currently, that operation is currently running behind the scene, and we can still click the button. In fact, this particular operation is more expensive than this one, because like this one runs on 50,000. Yeah, as you can see, it is done, and this is 500,000. But this one was 50,000 count. Yeah, now this is what we are going to be doing in this tutorial. And before we go on, if you haven't subscribed to my YouTube channel, please subscribe. It motivates me to do more tutorials like this. And thank you. Let's go to the full tutorial now. We are going to be using ElectronForge and the Vite plus Typescript template. If you are new to ElectronJS, you can watch my other tutorials on ElectronJS and the one that I also taught, ElectronJS plus React.js also. Yeah, and let's just copy this. This is all we need to create an ElectronJS ElectronForge Vite plus TypeScript application. So this is my terminal. Then I'm just going to paste that in the terminal. Then let's change it to Electron Worker. Then it's going to install the application and also dependencies. Yeah, while it is installing, I'm just going to pause the tutorial and then continue it after it has finished. Okay, the app has finished installing and it has also installed dependencies. Now let's move into the generated Electron Worker directory. cd. Yeah, now let's open it in VS Code. Yeah, let's open our app using npm start. Yeah, our app has opened. Now I'm just going to change the position of the console down. In fact, we don't really need console in this application in this tutorial. Yes, now next thing is let's remove this, and then let's create a button click me, then a div with id counter. Then this we can just give it, okay, there's no need to give it anything. Now let's go to the renderer.cs. This is where, if you are building an application with no framework, like if you are not using a framework in your application, like frameworks like React.js and all these things, this is where you are going to write all your JavaScript. Yeah, now let's select the counter, const counter l equal to document dot query selector, then counter, then the button equal to document dot query selector button, then btn dot on click, then that's going to be counter l dot text content equal to let's add the counter. Counter plus plus, then counter dot to string. Yeah, and don't let us forget to set this to 0. Yeah, we check this, then our counter is now working. Now the next thing is, now let's connect to the main process. If you are new to ElectronJS, you can watch my other tutorials, as I've mentioned before, where I talked more about the main process and the renderer process. And for the sake of this tutorial, I'm also going to briefly talk about the main process and the renderer process. In ElectronJS is divided into two processes. The main process, which is the part that access the operating system APIs, and the renderer process, which has the browser context, and it is literally the UI. Yes, like this is the renderer process, the UI of the application. Now, the renderer process cannot access the APIs that the main process can access, and the main process cannot access the APIs that the renderer process can access. Now, the both of them needs to communicate. Now, to communicate, they need something to communicate, which is the IPC renderer. Now, to do that, let's create a renderer object here. Then let's just set it to like start okay, start heavy counter. Then we need IPC renderer, which is going to be imported from ElectronJS dot send start heavy counter. Let me disable Gemini. Yeah, now if we declare this thing here like this, it's not going to automatically work. We need to expose it using the context bridge from ElectronJS. Then we need to expose in main word. Then we need to give it an API, like it's just a name, the name that we are going to use to access it in the global window objects. Like, let's just give it Electron. We can call it any name, but let's give it Electron. Now, this object that I created here, you can just pass it directly here, but for the purpose of, so that it's going to be easier to read, that's why I'm doing it like that. And then one more thing, because we are using Typescript T renderer, we need to add type of renderer. We need to add this renderer type to the global object, so that whenever we are accessing this Electron API from the window object, is going to be available, and Typescript is not going to be showing us error. Like if you try to access it now, window.electron, you see that this Electron in lowercase is not available on the global window object. Now, to make it available, we need to create a new file called global.d.ts. Then now declare global. Now then interface window, no. Then we need to add this renderer, this Electron, to its Electron. Then we are going to set it to the T renderer. Now, if we try to access this Electron API from the global window, it's going to be available dot Electron. Yeah, that's it. Any other objects any other fields that we are going to be adding to this renderer in the future is also going to be automatically accessible from the global window object. Now we are done with this. Now in the main process also, we also need to listen for this event that was broadcasted from the IPC renderer, and we are going to do that using you can create it anywhere, IPC main, which is the dot on, then start heavy counter. You can actually name this event any name that you want. Then it also inherits some things like events, then data. If you send any data from the renderer process, it's going to be here. Now after it has gotten here, we need to do something that is heavy, like let's declare a counter here equal to 0. Then let's use while loop. While counter is less than 50,000. Yeah, we can just use console.log counter. Then don't let us forget to increment counter, so that it's not going to lead to infinite loop. Yeah. Yeah, this should be enough to block the main thread. This is going to block the main thread because we are creating it in the main thread. Now let's save it, and to reload our app, all we just need to do is just type rs in the terminal, then enter. Then now okay, we need to call, we've not called this method from the renderer. Now we are going to automatically call it. Let's go to the renderer, then like document dot already state change. If document dot ready state complete, then we need to call window dot electron dot start heavy counter. Yeah, this is going to automatically call it. Then our main UI is going to be blocked. Yeah, that was fast. As you can see, my terminal is getting okay. It's not slow. Let's start. Okay, let's add more work to it. Now let's set it to 500,000. Then now you see that you cannot click this button, and everything is waiting for this to finish. Yeah. Now to fix this, we are going to create a worker. Let's create the worker inside a folder called workers. Then we are going to create the worker file, and it is, let's just call it counter.worker.cjs. The reason why I'm making it a CommonJS module is because it is recommended to use CommonJS when you are creating your worker, because when you are packaging your app for production, sometimes if you are using a third-party library inside this worker, you are going to need to bundle it to CommonJS. Yeah, because after or when bundling your application, ElectronJS is not going to automatically bundle everything, that is not going to bundle this worker alongside your app, and it is also not going to bundle anything that you import inside any third-party library is not going to be bundled with it. Yeah. Now though it is CommonJS, but you can still use ES6 terms like const. Then let's create main. Then let's call it main. Yeah. Now we've created it. Now let's go back. let's create another IPC event. Then let's start every event, every worker counter. This is going to use worker on a worker thread. In a worker thread, it's going to do this in a worker thread, and it is going to offload that work to a separate thread. Then let's create a new function called const counter fn equal to set that. Yeah. And let's come back to this place now. Const worker equal to new worker from worker threads. Yeah. Now we need to pass in the either like the absolute or the relative part to this worker. Then we are going to be using the relative part, which is going to be this dot slash start from the root of the directory, then src, then workers, then counter.worker.cjs. Yeah. Then if you want to pass in any data to the worker, you are going to pass it through this worker data. Then let's pass in an object with tests data. Then it's going to be hello world. Yeah. Now we are going to listen to some event dots on message. When the child process sent message is going to be received here, then we can just console.log msg. Then there are other events too that you can listen to. Dot on exit. This is going to be called after the worker has exited. Then is also going to return a code. If an error occurred in the worker, it's going to return an error event. Error. Yeah, that is all. Now, instead of requesting this heavy counter that is blocking the main thread, we are going to do it. We are going to do the work in the worker thread. Yeah. Now we are not done yet with this. Now, to access this data that we sent, we need to use the structure, then require worker threads. You can either use worker threads or node worker threads, then worker data, then parent ports. Now we are going to destructure it and get this text data. Const equal to worker data. Then when we are done, we are going to use parent port dot post message counter. I'm also going to be returning the counter just to show that counter fn, then no counter. Yeah. Then we can log this console.log. Yeah. Now that is that. Now let's test it out. Now to test that, let's go back to the main, then let's just copy this event name, then go back to the preload, then duplicate this, let's set it to the same name. Now instead of by default just calling it here by default, let's comment this out. Then let's create a button. Let's create like 2 buttons here. Oh, sorry, here. Then do like main thread, or let's work on main thread. Work on worker thread. Yeah. Now this, or let's just give all of them an ID. I'm going to give them an ID really quick. Yeah, so I gave this a default ID, main thread and worker thread. Yeah. Now let's go to the renderer.cs, then query selector, that's default. Yeah, then let's select other buttons, main thread, btn, that's worker thread. Yeah. Okay, let's give this and this as HTML button element. Then now main thread button dots on click. Yeah. Now if you click on this main thread start heavy counter, then if you click on worker threads, you are going to start heavy worker thread counter. Yeah, and that is all we need to do. Now let's refresh the app. Yeah. Now let's test this work on main thread first. If you click on it, you see we can't click on the click me until it's finished. Now if you click on worker thread, you see what's going to happen. See what's going to happen. Let me like clear the console so that we are going to see it very well. And let me move this. Yeah, then work on worker thread. As it is working, we can, okay, let me just like remove the console.log from there. Let me remove the console.log. Or because the reason is that it is not going to do the console.log. It's going to flush all the console.logs out after it has finished the operation. That's why. Then it is going to be instant also. It's also going to be instant. If I click on it, it's going to be instant. But let's add something like const fs equals require fs. I'm going to add a sync action so that it's going to slow it down a bit. Yeah. Yeah. Now if you click on it, you see that it is currently working. It's still working and everything is working here. We can still click this button finally and it is working. It is working well. Now it's going to return the data very soon, and we can still click on everything. Yeah, as you can see, it is done. Yeah, this is how you can offload like heavy operations that does heavy computations and that can block the main thread. You can offload it to a worker thread. Yeah, and yeah, we've come to the end of the tutorial. If you like this tutorial, please give it a thumb up. If you don't like it, let me know, and let me know your suggestions on how I can improve my tutorials. Thank you, and don't forget to subscribe to my YouTube channel. It motivates me to do more tutorials like this.